Everything around you, your phone, the world around us, the water droplets, and even you is made of something. Yes, matter. But what exactly is matter? And here's a crazy question. Can matter disappear or just change its form? Let's find out and understand in the next 10 minutes and understand what is the composition of matter. Today we'll be discussing the first chapter of class 8th ICSE, that is matter. Let's see a very simple example. If we have ice cubes placed on a tabletop, what you're going to observe? It's a very simple answer. All of you know the ice is going to melt and it is going to change into water. And if I'm going to heat this water, what is going to happen? Yes, the water is going to change into steam. So here we are seeing that the same substance is undergoing different change in its form. So different forms of the same substance, and we can call this as a simple example of the change of state of matter. And the simple example is showing us that ice, which is present in solid state, melts to changes into liquid state, and from liquid state it changes into vapor state. So this is a very simple example of change of state of matter. Let's understand what is matter. Let's keep it simple. It's a very simple definition. We list it out. Matter is anything that occupies space, has mass, and can be felt by our senses. So these three aspects you will remember in your definition for matter, that matter is anything that occupies space, has mass, and can be felt by our senses. Now let's quickly see some examples for matter. Yes, the water around us, the raindrops, the air we breathe, the air that surrounds us, and everything around you. It can be your school bag, your water bottle, and even your table and chair in your classroom. Everything is an example of matter. So what is matter made of? A very important question to understand. We all know that if matter is broken down into simple particles, those simple particles can be classified as atoms. And earlier also we have understood the definition of atom, that it is the smallest unit of an element. Atom is the smallest unit of an element. So matter can be made up of atoms, it can be made up of molecules, or it can be made up of charged particles, which we call it as ions. Okay. So if somebody asks you what matter is made up of, what will you say? It can be made up of atoms, molecules, or ions. Okay. So in class 8 you have to understand the main postulates of the kinetic theory of matter, and this main postulate has been classified under 4 important headings. Let's list them out. Firstly, the first postulate talks about the composition of matter, and it says that the matter can be composed of particles, and what these particles can be made up of? Again, atoms, molecules, or ions. So very important, don't get confused. The composition of matter, what composition means? What matter is made up of? It is made up of small particles, which can be atoms, molecules, or ions, and in general we are calling all these as particles. Next postulate, it talks about the interparticle space. What do we understand by this term? It is that how the particles are arranged. If for example I am seeing the arrangement of particles in solid state, what are we going to see? That the particles are closely placed together and the spaces between them is minimum. The spaces between the atoms is called as the interparticle space, and in case of solid the interparticle space will be the least. The third postulate of kinetic theory of matter talks about the interparticle attraction. What we understand by this? That the particles will be attracting each other with the force. The particles will be attracting each other with a force, and this force is called as the interparticle attraction. And later on we'll discuss that based on the three states of matter, which state of matter will be showing maximum interparticle attraction. Obviously we know solids, because the particles are closely placed, they will have maximum interparticle attraction. And lastly, talking about the energy possessed by particles of matter. Now because particles are in continuous motion, they'll be having kinetic energy. The kinetic energy will be present due to the continuous motion of the particles, and due to this continuous motion they'll be having energy, which we call as kinetic energy, and this kinetic energy increases on application of heat. More the heat energy, more will be the kinetic energy of the particles. So these are the four important aspects or the main postulates of the kinetic theory of matter. First is composition of matter, that is what matter is made up of. It is made up of particles. What these particles can be? Atoms, molecules or ions. Secondly, we have the interparticle space, that is the space between the particles, how they are arranged, that is interparticle space. Then the particles will be attracted to each other with a force, which is the interparticle attraction, and the particles will be in continuous motion, because of which they'll be having kinetic energy, and this kinetic energy will increase when we increase the heat energy. And lastly, we list out or see a comparative study of the three states of matter based on the kinetic theory of matter. Okay, so based on kinetic theory of matter, we will understand what postulates we had discussed earlier. We had discussed under three main headings: interparticle space, interparticle attraction, and the energy possessed by particles. Now what can you understand from the figures which are given over here for the three states of matter in terms of interparticle space? Now clearly you can see in case of solids that the particles are closely placed, because of which we will say that the interparticle space is minimum in case of solids. In case of liquids, it will be more than solids. And in case of gases, we can say that the interparticle space will be maximum. Based on interparticle space, what can we see about the arrangement of atoms or molecules? If we see the arrangement of atoms or molecules in solid state, the molecules will be closely packed. So how is the arrangement of atoms? They are closely packed. Then in case of liquids, what we can see in case of liquids, that the molecules will be less compact. And in case of gases, what will be the arrangement of atoms? We will say they'll be least compact. Then coming to the movement of atoms, because the atoms are closely packed in solids, they will just move about their mean position. About their mean position only they will move. About their mean position they are going to move. Then here in case of liquids, because they are less compact, the particles, so here the particles will be in continuous motion. They'll be in continuous motion. And in gases they will be in random direction, because the interparticle space is maximum in case of gases. So based on interparticle space, we have understood the arrangement of atoms and the movement of atoms. Next, coming to the interparticle attraction. Now because in solids the atoms are closely packed, the interparticle attraction will be very strong. Because the attraction will be very strong, we can say that the solids will be rigid, then they will have definite volume and shape. They will have definite volume and shape. Okay, then talking about liquids, based on the arrangement of atoms, it is less compact, so the interparticle attraction will be less strong. Okay, the interparticle attraction will be less strong, and because the interparticle attraction will be less strong, what can we conclude for the liquids? We can say that the liquids will be less rigid, then they have a definite volume but no definite shape. No definite shape. They will take the shape of the container. Okay, and gases, because the arrangement of atoms is least compact, we will say that the interparticle attraction will be very, very weak. And because the interparticle attraction is very weak, therefore gases will be less rigid and they will have no definite shape or volume. No definite shape and no definite volume. Okay, so these are the important points for the interparticle attraction between solid, liquid and gases. And lastly, talking about the energy possessed by particles, because the particles are closely packed, what we will conclude for solids, that the kinetic energy of molecules of solids will be least. Kinetic energy will be least. Here kinetic energy for liquids will be large and for gases will be very, very large. Because molecules are further apart, they will be undergoing continuous random motion, because of which the kinetic energy of the gases will be maximum. So this difference chart is very important. Please go through it. And in the next video, we'll be talking about the interconversion of the states of matter, and we'll also understand the interconversion based on the kinetic theory of matter. I hope you have understood. We'll meet in the next video. Thank you, students.